Okay. Do we have any questions about chapters 1 through 6? 1 through 6. Any questions on that? And any questions on the equation quiz, which is comprehensive, chapters 1 through 8? Okay. If not, I'm going to go ahead and go to the screen. We're going to do chapter 7, practice problems. I think I'll just use this board as opposed to putting it on a whiteboard. Okay, so in chapter 7, we had 3 equations, basically just 3 equations. We said that we define impulse, which is a vector, as F times delta T. And then we define momentum as mass times velocity. Then we had the impulse momentum theorem, which said that the impulse is equal to change in momentum. So those are 3 basic equations for chapter 7. So let's look at some problems. So these are practice problems, and then I will send you some, I'll put some on Blackboard for your homework. Okay. A golfer driving a golf ball off the tee gives the ball a velocity of 38 meters per second. So that means that initially the velocity is 0. And then he gives it a velocity of 38 meters per second. The mass of the ball is, so we got the mass of the ball, 0.045 kilograms. And the duration of the impact with the ball, with the golf club, is 3. So my time is 3 lowercase m. Someone go into chat real quickly and tell me, what am I going to put here for this m? Go into chat and let me know, what am I going to put for that m? What does that lowercase m stand for, someone? So go into chat and give me the value for lowercase m. Okay. No. Nigel, no. Someone else? Someone else? What does lowercase m stand for, class? No. No. Everyone's wrong so far. Milli, okay, that's right, milli. So what's the lowercase m stands for milli. So what am I going to put right here, though? Okay, class. In solving the problem, I want to have my SI units. My SI unit for speed is meters per second. For mass is kilograms. For time, it's seconds. So I can't put this m here, but I can replace that m with 10 to the minus 3. Milli, class, means 10 to the minus 3. Okay. So let me just go over here quickly and tell you what you have to know for the midterm, for the final. Okay, so you have to know centi. Centi is 10 to the minus 2. You have to know milli, 10 to the minus 3. Micro, 10 to the minus 6. And nano, 10 to the minus 9. So those are the common ones that is less than the whole. Then we have kilo, which is 10 to the third. We have mega, which is 10 to the 6th. Those are the main ones that we're going to be using. And sometimes we may see giga, but not too often. But if you do, it's 10 to the 9th. Okay. Now the question is, what is the change in momentum of the ball? What is delta? Okay. And of course, we know that change in momentum is momentum final minus momentum initial. And since VI is 0, there is no initial momentum. So we simply have mass times velocity final. So what do we have? Let's write this as 1, 2, 3. In other words, we have 45 times 10 to the minus 3 kilograms. 1, 2, 3. So if I go back, it'd be 1, 2, 3. So it's minus 3. That's my mass. And my speed is 38 meters per second. So in chat, give me my change in momentum. Someone give me that answer with the units. So remember, when you come to class, you must have your calculator. I've been noticing that some people are never responding, which tells me that you're not participating because you're not even able to put in simple multiplication answers from your calculator. This is my way of gauging whether you're even in the classroom participating, because it's not that difficult. Okay, now, once you give me the answer, I want you to do this. Okay, first of all, multiply 45 times 38, you'll get 1710. Okay, times 10 to the minus 3 kilogram meter per second. So how would I write that number in scientific notation? So when you give me your answer now, -3 means find my decimal, which is at the end of the problem, and go back 1, 2, 3. So my answer is just 1.7. And the reason why I'm going to stop there with 1.7 is because in the given, I have 2 sig figs, 3 sig figs, or no, I'm sorry, 2 sig figs and 2 sig figs. So therefore, I need to just go ahead and write that with 2 sig figs, kilogram meter per second. Okay, let's see what you all have. Okay, so Lex and Kaylin are participating and they're getting the extra points. Okay, Keston answered earlier. So I haven't heard from Lanisha, haven't heard from Kendra, haven't heard from Monier, but I'll give you all chances to weigh in and show that you want these extra credit points. Okay, let's look at the second problem. I'm going to go ahead and clear this. Okay, first of all, any questions? Oh, I'm sorry, look. Part B, determine the average force applied to the ball by the club. So to do that, let me just number these. Number 1, number 2, number 3. Okay, class. What am I going to do to find the average force? Which equation am I going to solve to find the average force? 1, 2, or 3? No answers? Okay, number 1. Now, please tell me, the rest of you, why you couldn't just weigh in quickly and tell me that in order to solve for the average force, that I would use equation 1. In other words, equation 3 tells us that the impulse is equal to the change in the momentum. So we have just found the change in the momentum, and therefore we can find the force because the change in momentum is the impulse. So now we know what this value is. So in other words, 1.7 kilogram meter per second is also my impulse. So with that being said, what is my force? Okay. This equation, please solve for the force. I need to hear from Lanisha and Kendra. We're solving for the force. Please solve for the force. I'm looking for the force, class. I don't believe y'all are here today.
I'm here. I'm just trying to solve for the. I don't think I'm solving it the correct way, actually.
Okay, well, look at this. You're looking for force, right?
Mm-hmm.
The impulse is equal to the change in momentum. That's what number 3 tells us. So if I know the change in momentum, I know the impulse.
You just divide J divided by T to get F, right?
Exactly. That's so
Okay.
easy.
Okay.
So when I solve for the force, I'm going to say the impulse, which is 1.7 kilogram times meter per second divided by time, and time is 3.0 times 10 to the minus 3 seconds. So I've got kilogram meter per second, which is kilogram meter per second squared, which is a Newton. So I've got 1.7 divided by 3, and I get 0.566. But look, this negative 3 in the denominator moves to the numerator, and it becomes positive. So therefore, I have 566 newtons. Did everybody get that? Now, if I want to write that in with 2 sig figs, I would say 570 newtons, and that would be my answer.
Can you explain how we get the change in time again? T.
Okay, so in here in equation number 1, okay, the author told us that the duration of the impact with the golf club was 3 milliseconds. That's my delta T. So my delta T now is just T because it went from 0. In other words, this delta T here means T final minus T initial. But T initial itself is 0. So that's nothing there. So T final is just delta T, and we just call that T. So so this T is what I have given.
And then the 10 to the negative third is because it's milli.
Right.
Okay. I'm sorry. I get it now.
Yeah, the milliseconds is minus 3. So therefore, when I come here and divide 1.7 by 3, I'm going to get 0.566. But this negative 3 is in the denominator. When it comes to the top, it becomes a positive 3. And therefore, I'm going to move that, 1, 2, 3 times. Then finally, my answer needs to have 2 sig figs because of what was given in the problem. Okay. So if you have any questions. Okay. Now, one of the things that you have to do as you study class is to make sure you identify what these variables stand for. For example, J stands for impulse. So when we're looking for the force, and we know that we don't have an equation that says delta P equals force times delta T, but we have an equation that says that the impulse equals the change in momentum. So all of this you have to internalize in order to be able to understand it and to use it. Okay, I'm going to clear this. We're going to try another problem. Okay, I'm going to try number 2. Okay. All right, so don't forget, we have 3 equations. We define the impulse to be the force times delta T. We define the momentum to be mass times velocity. And we define we have the impulse momentum theorem, which says that the impulse is equal to the change in momentum. All right, what's given in the problem? A baseball with mass 149 grams. Now, because it's in grams and not kilograms, I want to write this answer in kilograms, which means I can either say 149 times 10 to the minus 3 kilograms, or I can just say 0.149 kilograms. So on your equation quiz, you have there that 1 gram is 10 to the minus 3 kilograms. Okay, 1,000th of a kilogram is a gram because it takes 1,000 grams to make 1 kilogram. Okay, approaches a bat horizontally at a speed of 40.2 meters per second. So they tell you how fast that is in miles per hour. But we're going to keep our SI units. So we have 40.2 meters per second. And it's hit straight back at an average speed of, now this is what's important. If V initial is, we say, moving toward the right, that tells us that V final, if it's hit straight back, has to have the opposite sign. Remember, these are vectors, and we have to account for the sign. So it says if the ball is, is hit straight back at a speed of, so this is my new speed, but it's negative. That's important to observe. If the ball is in contact with the bat for a time, so my time now is 1.1 times 10 to the minus 3 seconds, milli minus 3. What is the average force exerted on the ball by the bat? So what is force? Neglect the weight of the ball since it is so much less than the force of the bat. Remember, weight is also a force, but we're neglecting that because this force is going to be so much greater, it's going to be negligible. Choose the direction of the incoming ball as positive. So if incoming is positive, then going back then is negative. Okay. So are we going to use first equation 1, 2, or a combination of 1, 2, and 3? And if so, do you understand why? You see, my force is my unknown. And my force times time is my impulse. But I'm not given the impulse. But I do know that the impulse is equal to the change in momentum. So I'm going to use the fact that the impulse is equal to the change in momentum, and the impulse is equal to the force times the time. And this force is what I am looking for. I'm given the time, I'm given momentum, because I know both the mass and both speeds, so I can find the change. So I say that the force is equal to the change in momentum divided by the time. So now I will say the change is the momentum final minus the momentum initial divided by the time. Now, remember, momentum is mass times velocity. So I have mass times velocity final minus mass times velocity initial divided by time. Now, this mass is a common quantity in these two terms. So I'm going to factor it out. So I have mass, velocity final, minus velocity initial, and that is over time. So now I can plug in my values because look, everything here is what I have given here. So let's begin with my mass. My mass is 149 times 10 to the minus 3. The final is negative 45.6. So I've got negative 45.6 minus initial is 40.2. And the units in both cases is meters per second. And I divide that by time. And time is 1.1. Oh, right here, left off my kilograms. 1.1 times 10 to the minus 3 seconds. So minus 3 and minus 3 will cancel. So I have 149 times, this is 45.6 minus, so the whole thing is negative. So I got, that's 0.8, 5, 4 and 4 is 8. So I got 85.8. And this is, the units are kilogram, meter per second. Divide that by 1.1 seconds. So, okay. So it says, if the ball is in contact with the bat for this much time, what is the average force exerted on the ball by the bat? And if you notice then, this number needs to be negative, which it will be, because this force that's exerted on the ball by the bat, when the ball is coming in like this, the force sends it back in this direction. And that's why you know that this number needs to be negative, because when the ball comes in, it goes back in this direction. So therefore, this number needs to be negative because it's heading away from the incoming direction. Okay, so let's see if you can put that number in your calculator. You shouldn't have any problem putting that number in your calculator and getting the correct answer. Now, the reason why I'm walking you through these problems, so you will have a model for your homework. And you have to do your homework very, very methodically so that you will have a good answer. So I got that, and I'm going to divide that by 1.1. Okay, so let's see what you all getting. Okay, very good, very good. All right, now let's look at our sig figs and what we should write here. So if we look at this problem, this answer has 3, 3, 3, 3. So the author wants us to write this with 3 sig figs. We can do 1, 1, 6, 0, 0. That's 3 sig figs, because the number after 6 is less than 5. So that means that these numbers that trail that needs to be 0. They cannot be significant numbers. Or we can write this as 1.16 times 10 to the what? 1, 2, 3, 4. 4. Then we have kilogram meter per second squared. And of course, that is a Newton. So that gives us the force. Okay. So that's how those type problems are solved. Let us go now to another problem. Anybody have a question before we move on? Okay. I'm going to try to send you all of these recorded videos so you can have it to study over the weekend, over the holiday, if you want to do your homework and refer back to it. Okay, so now I want you on your own to work on number 3. And then we have another one we're going to do it together. Okay, number 3. Work on it, and then put the answer in chat. Okay, so I'll give the equations again. Okay, I'm looking for the answer to number 3. Let's see if anybody's put the answer in. I have something to point out with number 3. That's why I want you to do it and put your answer in so I can show you something that's, I want to see if I can bring this to your attention. Number 3, please. It's a very simple problem. Are you having difficulty doing number 3? Yes or no? Put in if you're having difficulty doing number 3. No one's answering. Okay, Nigel has the right answer. Anyone else? Nigel, look at your unit. Remember, this is impulse. So what's the unit for impulse? Okay, so I see that someone is trying to figure out which equation to use. So these are our 3 equations. And you're looking for impulse. It says, what impulse does the player apply to the ball? If we were given the force and the time, we could find the impulse from equation number 1. But since we're not given the force and the time, we're forced to use equation 3, because equation 3 tells us that the impulse is equal to the change in the momentum. And since we know that we're able to calculate the change in the momentum, then we're able to calculate the impulse. So that's where you start. You say the impulse is equal to the change in the momentum, which is the momentum final minus the momentum initial. The momentum is defined in equation 2. Mass times velocity final minus mass times velocity initial. If I factor out the mass, I simply have velocity final minus velocity initial. So velocity final was -21 minus initial, that was 4. So then I have my mass, which is 0.35 kilograms, minus 25 minus 4 is minus 25 meters per second. And when I do that math, I get a negative 8.75. Now, the important thing though is this. If I put kilogram meter per second, that is the unit for momentum. So in this case, rather than saying kilogram meter per second, I use the unit for impulse because it asks for the impulse. And the impulse is 8.75 Newton second. Because see, impulse is in the unit of force times time, which is Newton second. Okay, let's see who got that one right. Newton second. Okay, very good. That's the unit for impulse. Now, I was hoping that this chapter would be the easiest of all because we only have 3 equations. And you have to say the equation in order for it to make sense to you. In other words, you have to say that impulse is equal to change in momentum. What is change in momentum? In other words, what is momentum? It's simply mass times velocity. And that way you will be able to solve it like I did here. But you have to practice. If you don't practice, you just won't ever get it. Okay, let me go to another problem in this section. We're going to end on this problem. I want to show you this problem because it's in your homework. I don't want you to not have had a chance to work on it. Okay, so the problem I'm going to do is number 6, collisions in 2 dimensions. But we're only going to do an easy one in 1 dimension. So I want to show you now in one like number 7, you have to have some subscripts, okay? So Kevin has a mass of 87 kilograms. Let's denote that as the mass of Kevin, 87 kilograms. Is skating with inline skates. So if he's skating, that means he has some velocity of Kevin. He sees his 22 kilogram younger brother. So we'll say the mass of the brother. And his brother is 22 kilograms, much smaller. Okay, he sees his 22 kilogram younger brother up ahead standing on the sidewalk. So that means that the velocity of the brother is 0 because he's not moving. Okay, on the sidewalk with his back turned. Coming up from behind, he grabs his brother and rolls off with a speed of. So he grabs his brother, which means then that becomes 1 mass. So this is my new mass. I'm going to call this mass after the collision. I can call it anything. But that mass will be Kevin plus his brother. So 87 plus 22, that's what, 109. So 109 kilograms. That's the mass after the collision. And then they go off with a speed of 2.4 meters per second. Ignoring friction, find Kevin's speed just before he grabbed his brother. So this problem is solved by using the conservation of momentum. Momentum before. Everything moving before must equal everything moving after. And after means after the collision or after the interaction. So what was moving before? It wasn't his brother because his brother was at rest. So it was only the momentum of Kevin, which is mass of Kevin times velocity of Kevin. And that must equal the momentum after. And after we have Kevin plus his brother and their velocity. Okay. Now, the mass of Kevin was given. So if I divide both sides by the mass of Kevin, that will come over on this side in the denominator. And that number is 87 kilograms. So kilograms and kilograms will cancel. And I will get the velocity of Kevin because my only unit remaining is meters per second. So now I have 109 times 2.4 and divide that by 87 and I get 3.00. So I'm going to say 3.0. So I get 3, oops. Well, all right, my pen has gone out again. But if you put in your calculator, you should get 3.0. And of course, that would be meters per second. Okay, very good. All right, so now I have covered the type of problems you're going to have in your homework for chapter 7. So rather than going on to chapter 8, we're going to get out early today. I need for you to sign your name as you exit. Even though I haven't gone over the ones for chapter 8, I'm going to send those anyway, and we'll start there on Tuesday. Remember, Monday is our 4th of July holiday. So enjoy your holiday. Don't eat too much barbecue, but have a good time. And do a little studying while you're away so that you won't come back without knowing some of the content from chapter 7, and also look at chapter 8. Also on Blackboard, I think I've placed everything except for the content from chapter 8. And I'll put that up there soon. Okay, enjoy your weekend, and we will meet on Tuesday.
All right, have a good weekend.
Okay, you too.